Good day, everyone. Today we are talking about section 2.4, write equations of lines. Our learning targets for today: I can write an equation of a line from a point and a slope. I can write an equation of a line from 2 points. And I can write equations of parallel and perpendicular lines. So we start with, there are 3 different sets of given information that we're going to be working with, and depending on what we're given, it's going to depend on how we're going about solving it. If you recall, again, the slope, we use the letter M to represent, and the y-intercept we use with the letter B is our symbol. So if we're given M and we're given B, we can use our y equals mx plus b, our point slope formula. I'm sorry, our slope-intercept formula, y equals mx plus b. Again, if you're given slope and given the y-intercept. Now, if you're not given both of those, maybe you're given the slope and then a point, and so we call this point x1, y1. It's a coordinate point. Well, when we're given this, there are 2 different methods, and you were probably shown one method in middle school, and I'm going to show you what's called using the point slope formula. If you're given a point and the slope, we're going to use this formula: y minus y1 equals m times x minus x1. And we'll get into how to use this here in a moment. And our last option is if we are given 2 points. So the 2 points we're given are going to be x1, y1 and x2, y2. And if this is the case, it's kind of a 2-step process. So the first part of the process is we need to know the slope. So the first thing you're going to do is you need to find the slope. And again, slope formula y2 minus y1 over x2 minus x1, as we talked about in section 2.2. Once you have the slope, we now have the conditions that we had for slope in a point. So then we're going to use the point slope formula. That formula right there that we talked about in the second option. So really, if you're given everything you need, you're going to go plug it into y equals mx plus b. If you're not, like if you're given a point or 2 points, eventually we're going to be using the point slope formula. So let's look through a couple examples here. Again, this is like the first example. You're given m, you're given b, so it's just a matter of plugging these values into y equals mx plus b. Now, could you go, instead of just writing -4, could you go plus -4? Yes. We as mathematicians generally shortcut everything and just write it as 2x or -2x minus 4. Either one of these are acceptable. Take a quick moment, pause the video, try the next one. All right, so on this one, you should have had y equals -3/4 x plus 7/2. Not great for graphing one with a bunch of fractions and stuff, but if we're just writing the equation of a line, not so bad. All right, we're going to look at the next type of problem here. So this one says through the point, and again, the point we're given is x1, y1 with a slope of 4. So we are going to plug this into the point slope formula. So again, we're going to have y minus the y value we're given equals our slope times, and then x minus the x we're given. Now you will see that I, put this as minus -1 because the formula is x minus, and I want to get in the mindset and the habit of going x minus every single time. Then what I will do is I will clean this up. So on the left side, there's nothing to clean up. On the right side, I'm going to distribute. And when I'm doing that, I'm going to say a double negative becomes a positive. So 4 times x is 4x. 4 times +1 is +4. My last step, I want y equals, because we're writing the equation of a line. So whatever value is next to the y, I need to move over. In this case, I'm going to add 6 to both sides. And you'll see that, when I'm adding 6, I'm adding it to the constant here, which is 4. And I get y equals 4x plus 10. Notice my answer's in the form y equals mx plus b. When I'm using point slope formula, really what I'm doing is I'm using y equals mx plus b. I'm just using a modified version to accommodate being given a point. If you feel comfortable with this, go ahead, pause the video and try the next one. If you don't feel comfortable, I'm going to walk you through this one as well. Again, x1, y1 is the coordinates of the point, and the slope we're given is m. We're going to plug this into the point slope formula. Again, the coordinate points are x1, y1. The y and the x, the plane y, the plane x, are going to be in your final answer. Again, we distribute, so we get negative 3x plus 15. Nothing happening here on the left. Again, I need to get y by itself. So I'm going to add the 4 over. It just so happened both of these examples are adding, but there are cases where you will subtract, because if I had a double negative, that becomes a positive. All right, our next topic is parallel lines. And as we discussed earlier, parallel lines have the same slopes. So this is another one of these types of problems. It says write the equation of a line that passes through, well, here's a point, so there's x1, y1, and is parallel. So we have to read carefully. So this one says parallel. That means it's going to have the same slope. And it's parallel to the line y equals negative 4x plus 1. Well, all we don't care about the y-intercept because we're talking about a different line that's parallel. All we are concerned about is this slope. So all we're going to do is say that the slope is negative 4. We can now use this, or you can say parallel slope, and we're going to now do the same thing we were just doing. Plug this into the point slope formula. So y minus the y we're given equals the slope times x minus the x we're given. Again, we're going to distribute. Nothing to work on the left side. Negative 4x, again, double negative is a positive, minus 8. And this is, we're going to add the 3 over. And we get y equals negative 4x minus 5. And so this is the line parallel to the given line through the point negative 2, 3. What I'd like you to do is pause the video and try the next one on your own. All right, so again, our parallel slope is the same. So the slope of this line that we're given is 3, so our parallel slope is 3. We're given our coordinate points. In this case, we have y minus a negative 2 because our y value was negative. So you can see when I rewrote it as y plus 2. You could go here and make that a plus as well. Again, distributing, so that's where the 3x minus 12 came from. Subtract the 2 so that y is by itself, and we get 3x minus 14. The other type of lines we're going to talk about in this section are perpendicular lines. And we talked about perpendicular lines, and we know that they have opposite reciprocal slopes. Again, we are given a point, x1, y1. So write the equation of a line that passes through. We're given a point and is perpendicular to y equals negative 4x plus 1. Again, we do not care about the y-intercept. Now, we want opposite reciprocal of this. So the perpendicular slope is going to be the opposite reciprocal of negative 4. Well, remember, all integers are a fraction over 1. So the opposite will be positive. The reciprocal part, 1/4. So our slope in this case is 1/4. Yes, this could get messy because we're going to be dealing with fractions. So we're going to have y minus the y we're given equals our slope times x minus the x we're given. And again, a double negative becomes a positive. Distribute 1/4 times 2 becomes 2/4, or 1/2. We're going to add 3, and we get y equals 1/4 x plus 7/2. Go ahead and pause the video and try the next one on your own. All right, so again, our perpendicular, so we're talking opposite reciprocal. So the opposite reciprocal of 3 would be -1/3. So our perpendicular slope is -1/3. We plug it in our slope formula, y minus the y we're given. So y minus -2 equals the slope times x minus the x we're given. Distribute. If you're not good, you may remember doing 4/3 minus 2/1, finding your common denominator and stuff like that. We will talk more about this in class and using your calculators and all of that stuff as well. All right. Our third option when we're dealing with these problems was given 2 points. So again, when we have our 2 points, our first one is x1, y1. Our second one is x2, y2. And so in order to find the equation of the line, we need to know the slope. So we're going to calculate the slope using our slope formula, y2 minus y1 over x2 minus x1. So we're going to do this work to find our slope. Once we have our slope, it is now just like the last 5, 6 examples that we've done. Now, instead of being given 1 point, we're given 2 points. You can pick. Most people would pick, like, I'm going to pick this point simply because both of the values are positive. So I don't have to worry about messing up like a double negative or something. So I'm going to go y minus the y we're given equals our slope times x minus the x we're given. Again, clean up the left side, distribute on the right, add the constant over to get y by itself, and we get y equals -4x plus 18. I would like you to pause the video and try the next one on your own. All right, so again, we found the slope as we did here. In this case, we found it to be 1/3. I know fractions aren't fun to deal with, but that is life. We're going to deal with fractions. Again, plug it in the point slope formula. Again, I picked 4, 7 because both of the x and y values were positive, and I find those easier to work with. Distribute, add the 7 over, and I get y equals 1/3 x plus 17. All right, our last example of this has a graph. Many people get confused or find it difficult when we do a graph, so we're going to go through an example using a graph. We still have 2 points. So we have the points 4, 4, and 3, -1. So if you just wanted to go, my points are 4, 4, and 3, -1. This is now just like the problems above. Go ahead, pause the video, solve this problem. The other thing you can do is, just like we've been doing, but instead of having to actually calculate the slope, you can count on a graph. Again, rise over run. So we look at going, how far up do we go? Well, we go 1, 2, 3, 4, 5. And we go over 1. So 5 over 1, or 5. So our slope is 5. Again, you can count. Just remember, when you are counting, you are always going from left to right. So whichever point is further left, in this case, this point down here, that is where we are starting, and we are always counting to the right. Because remember, it's always rise, which could be up or down, but run is to the right. All right, now that you have your slope, this is just like any other problem, so go ahead, pause the video, and finish this problem. All right, and hopefully when doing it, again, I chose 4, 4. You could do 3, -1, your choice. Hopefully you got 5x minus 16. All right, the last couple problems we're going to look at are word problems. And a lot of people think word problems are difficult, but as we see, word problems are actually pretty easy of this type because they go back to the first type of equation where they give you the y-intercept and they give you the slope. So this problem says you buy a used car for $16,500. The monthly cost of owning a car, that includes insurance, fuel, maintenance, and tabs, averages about $400. Write an equation that models the total cost of buying and owning a car. So your total cost is going to be how much you pay for it plus the monthly expenses. So our total cost, well, when we look at this, when you buy it initially, that's your initial value. We also call that the y-intercept. So we know that this is going to be plus 16,500. Monthly cost, well, this is going to change for the more months you own it, the more it's going to be. So in this case, it's 400 X. I'm using X. You could use M for monthly, but I'm just going to stick with X. So a couple reminders here. Again, your y-intercept is your initial cost or value. Your slope is going to be something per. Dollars per month or per week or per hour, whatever your rate, that is your slope. Again, your slope is your rate of change. So take a moment, pause the video, read through this problem, see if you can write the equation, and then check back. All right. So it says a plumber charges $25 for a service call. So that is your initial fee. You pay that regardless of how long they're there. Plus $50 per hour. Again, there's your per, there's your rate of change, there's your slope. Write an equation in slope-intercept form for the cost C after H hours. So in this case, it's telling us which variables to use. Now, if it didn't specify, we would say y equals 50x plus 25. But since this one specified, that is what we're going to do. Now, there's a part 2. What will the total cost for 8 hours of work be? Plug 8 into your equation. So C equals 50 times 8 plus 25. Well, 50 times 8 is 400, so the cost equals $425. If you have any questions, make sure you ask in class. Otherwise, have a great day, everyone.